Hello everyone. Today we'll be seeing what is a two-pass assembler. Before that, let us have a look at what is forward reference problem. Now, by looking at this program, if we can find out 5, 4 and 10, these are the three variables which are actually memory locations. But the declaration of these variables are done later on, that is after its usage. Hence, if this program is given to an assembler to assemble, it becomes difficult for it to find out the memory locations of these given variables. As a result of this, a two-pass assembler is developed. Pass number 1 is used to fix all the symbols, make the entries into the respective tables, and calculate the location counter. Pass number 2 is used to substitute the values, the location counter values, into the respective places. Let us directly have a look at the databases which are used for processing this. This is the machine opcode table known as MOT. The first column is the machine opcode, that is the opcode which is used for doing the calculations. Usually these opcodes are always imperative statements. Imperative statements are those statements which cause the assembler to perform some task. The second column is the binary opcode, that is the hexadecimal equivalent of this code. Third is the instruction length, and the fourth the instruction format. The fifth column is not in use by IBM 360. Now, with respect to this program, let us see how to make the entries into these tables. Now, if we check, we have entered the mnemonics into this table. The mnemonics are L, A and ST. These are the three imperative statements which we have used in our program. The binary opcode. This binary opcode is supposed to be the hexadecimal equivalent of the binary, which is caused due to this mnemonic opcode. But for simplicity, we can maintain it as a binary opcode only. The third is instruction length. Now, the length of all these instructions will always be 4 bytes by default because these are RX format. Now, what is RX and what is RR? Going back to our program, if we see the instruction is L1, 5, where 1 is a register but 5 is a memory location. If 5 is a memory location, this format is called as RX. Whereas if we write an instruction of this form, LR1, 2, this stands for load register, and 1 and 2 both are registers. Hence, size of these instructions are usually 2 bytes. But size of any RX format is 4 bytes. Hence, we say that the instruction length is 4 bytes. Now, in IBM 360, we can mention 4 bytes as 10, that is 2 half words. Then comes the instruction format. Now, as I told you, there are two ways in which we can specify the instructions. One is RR, that is 000, and one is RX, that is 001. So we specify the instructions using 001, that is RX format. This finishes off with MOT. This is a table which is directly available to your assembler. This has been designed already by the person who designs the assembler. Next is the pseudo opcode. Now, pseudo ops are some of the opcodes which are predefined inside your assembler, which have a predefined meaning, and on encountering these opcodes, we actually give a call to an internal subroutine. Those opcodes are drop and EQU start using. Now, as per our program is concerned, we have three pseudo opcodes. Those are start, that is using, and end. So these three pseudo opcodes already have a predefined meaning. So the entry into the pseudo opcode table will be simply in this way, where we will be putting all the pseudo opcodes which we have, and the address of the routine simply we can write down the address where it needs to go. Now the next table will be symbol table and literal table. Symbol table or literal table usually encounters the variables which we declare in our program. Now as per our programming is concerned, we have John 4, 5 and 10. Please note that the name of the program is also something which is new to an assembler, and the assembler will never try to assemble this. Hence this is an external variable, hence it has to be entered into a symbol table. So these four things we are going to enter into the symbol table. Then the next column is the value. Now this value is the hexadecimal equivalent of the location counter where these symbols are present. Now just have a look at the program. Now 4 is present at location number 12, 5 is present at location number 16 and temp is present at location number 20. So hex equivalent of all these things are converted and put here accordingly. Also, since the first one is the name of the program, its value by default will be 0. Considering now the length of 4, 5 and temp will by default be 4 because we are using DCF over here. F indicates a full word which is going to give you 4 bytes. The last column, that is relocation, R or A, all these bits are relocatable bits. The meaning of relocatable means if I change the base address of my given program. Now right now the base address I am using is from 15. Now if I move this to somewhere around 20, my program will change its index accordingly. That is the meaning of relocatable. If I maintain this as absolute, even if I change the base address, there will be no change into its physical address. This is how, with respect to the program, I have entered the details. Now here, the value instead of hex, we can also directly put the location counter decimal over here. Same way we can do for LT. Of course, in this program, we are not encountering any literal, hence we are not making the LT table. But if we encounter any literal, the same kind of entries need to be put in the literal table. Last, we come with the base table which is formed at the end of your pass2, where we indicate which base register we are using. Now, as per our program is concerned, we have written using star comma 15, which indicates that 15 is the base register where we are starting our program. So that is why we just occupy 15 and the others we keep it as N. Just a brief description of what pass 1 and pass 2 are doing. Your pass 1 defines the symbols and literals. Specifically, we make entries into the symbol table and the literal table. We refer to the entries from your MOT and POT. We come to know which are the three types of statements, that is your imperative, assembler directive and declarative statements, and accordingly we make the entries into the respective tables. Pass 2 usually generates the object program. Thank you.